أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم السلام عليكم ورحمة الله. I welcome you all again. In today's class, you should be able to do at least two activities. Activity number one is to state the principle of flotation. Activity number two, solve simple problem on the principle of flotation. Okay. Here is the principle of flotation, and it is a consequence of Archimedes' principle that we learned in the previous video. Okay, principle of flotation. It says that the principle of flotation states that when an object floats, okay, if an object floats in a liquid or in gas, okay, let's say you have a container of water here, and then the water is at this level, and then you have an object on top of it. The object does not sink, it is floating on top of the liquid. Now when this happens, it says that the principle says that its weight is equal its weight, meaning the weight of this object on top of the liquid. You know, it has weight here. Okay, now the weight of the object is equal to the weight of fluid displaced. Remember, I told you that if an object is totally or partially immersed, the liquid level will go up at least it will go up. Okay, then this is the volume that goes up, and this volume has weight, and that weight is V rho G, where rho is the density of the liquid here, okay, G acceleration due to gravity. So according to the law of flotation, if an object is on top here floating and does not sink, then the weight here is equal to the weight of the fluid. This is weight of fluid displaced, okay, and then here this is weight of object, weight of object. The two are equal. The two here, this one and this one, are equal. If this one is 50 Newton, this one is also 50 Newton. And this means that for an object to float in a liquid, it has to displace volume of liquid, so that the weight of the liquid displaced should be equal to its weight. If it is not equal to its weight, it will sink. And this explains why ship can float in water, because from the shape of the ship, if you look at it in water, it is shaped in such a way that from the two sides it will displace large volume of water. And when you get all the volume of water displaced and you measure the volume, then you went on and measure the weight of that water. The weight of the water is equal to the weight of the ship, and that is why the ship will not sink. Okay, but when you can get another object as small, much smaller than the ship. Like if I get an iron needle can sink. Why? Because from the shape of the iron needle, it does not displace a large quantity of water, large enough to balance its own weight. It only displaces small quantity of water, and that small quantity of water, when you take it and measure its weight is less than the weight of the needle, so it does not balances that weight, so it has to sink down. This is an important principle in physics. Now we are going to look at a problem on this principle of flotation, inshallah, and you can see I call it problem 1. The problem reads, it said the density of ice is 917 kilogram per meter cube. We see ice is from water. When water freezes to ice, its density reduces. As we know that for water in liquid state, pure water, the density is 1000. And look at this one, they say ice, and we know ice is from water. It means when it freezes, the density reduces. This is because when ice is freezing, the volume increases. It is expanding when it is freezing, and that is why the density reduces. Okay, what fraction of the volume of a piece of ice will be above the liquid when floating in fresh water? Okay, because its density reduces, it can float in water. Because if I have in general, if I have a liquid, okay, then I bring an object and the density of this object is less than the density of the liquid here, then this object can float in the liquid. Okay, that is it. So because the density of ice is less than the density of water, when you bring ice and water, the ice will not sink, it will be on top of the water. Okay, here is our question. Our question is, let's say we have the water here, okay, and then we have the ice here. This is our iceberg. A portion of the iceberg is out and another portion is down. You see, this is a body of water. Okay, I have water here and this is my iceberg, for example, and then we know that its weight is acting downward. This is weight of the ice, we can call it W sub I, and then it must have displaced some volume of the water. Okay, the weight of water displaced is equal to the volume multiplied by density of water multiplied by acceleration due to gravity. And then the weight of this ice is the volume of the ice, density of the ice, and acceleration due to gravity. Remember, this volume is volume of water displaced, but this volume is the entire volume of the ice. Now, according to the principle of flotation that we have just read, the two weights are identical. If you have 50 here, you have 50 here. So it means we can say the weight here is equal to the weight there. So we can equate that and simply say, from the principle of flotation, from the principle of flotation, the weight of the ice is equal to the weight of water, the weight of water displaced, and the weight of the ice. Look at the weight of the ice is this, so you can say V sub I rho sub I G is equal to weight of the water displaced is here, V sub D rho W, okay, V sub D density of water G, and clearly the G will cancel from both sides, and I have V sub I rho sub I, and this is equal to V sub D rho W. Okay, let me explain something here. This volume V sub D, the volume of liquid displaced, is the volume of the ice, the portion of the ice that is immersed in water entirely. Okay, but this V sub I is the entire, it includes this one, complete iceberg. Okay, so if they say, the question says, what fraction of the volume of the piece of ice will be above the liquid? So they need the fraction above the liquid, meaning this is the fraction they want, but we may not get it at first. We will have to get the fraction of this bottom, then from there we can get the fraction of the one at the top. How do we get the fraction of the one at the bottom? We will say V sub D divided by V sub I, and the easiest way of doing it is start from here. You see, V sub D, then divide it by this V sub I, and say is equal to, then start from this side and take rho sub I divided by rho W. You see, if you cross multiply, this one will give you this, and then this one will give you this. Let me repeat that. Take this one divided by this one is equal to, then don't go back and say this divided by this again. Start from here and go back. This divided by this is equal to now this divided by this, and you have something like this. Now this is equal to if you go to the problem again, this is the density of ice. Density of ice is 917. You see, 917. So I have 917 divided by density of water is 1000. The two densities have the same unit, the unit will cancel. So I will have I will take your calculator and say 917 divided by 1000, and this will give you 0.917. Okay, this is the fraction that is below water. This is the fraction that is below water. Okay, now if I want to know the one that is above water, the fraction of the ice above water, I will say fraction of ice above the liquid, which is water, above a liquid, and of course is water. You just say 1 minus the fraction you just obtained, 0.917, and this is equal to oh, I have something here, great. Take your calculator and say 1 minus 0.917, and you have 0.083. If you change this to percentage, you will now say 0.083 multiplied by 100. Multiply the answer by 100 and you will get it in percentage. This is 8.3%, and this means that of the entire iceberg, only 8.3% is above water. The remaining 91.7% is below water, and this is why I drew it like this. You see, larger portion of the iceberg is below water. Only small portion, this portion is only 8.3% that is above water, and then the entire remaining, which is 91.7%, is below water. And with this one, you have successfully solved the problem, and this is the end of our today's video. Assalamu alaikum wa rahmatullah.